I want to make an announcement about the office hours. So part of what you're turning in Tuesday is the office hours schedule that you're getting 3 people to sign. There's somebody new. So since we've talked, Owen, who is the other instructor of this course, his office hours are available to you as well, 9 a.m. Monday, Wednesday, Friday. So that's another person that you can get a signature from and get help from throughout the semester. Okay? So this is the full schedule now, and you're going to print this out and get the 3 signatures of 3 different people by visiting them in their scheduled office hours. And you want to go at times when you'll be able to go this semester, so you find out where that place is, meet that person if you haven't yet, and you feel comfortable going there for help, because lots and lots of you, most of you are going to need support outside of class. So that's why we're giving you all these office hours. Yeah. What's that?
Everyone, I'm at a conference tomorrow, so my office hours are changed just for tomorrow, and I'll send out an email, okay?
2:30 to 4.
Tomorrow.
So tomorrow she's pushed back to 2:30 to 4. That's just tomorrow for Friday office hour, 2:30 to 4. Make a note of that. Okay. So and then our first exam is a week from tonight. A week from tonight. Okay. And I'll keep. We'll remind you about that Tuesday. And I'll post, so before the weekend, I'll post a review outline so you can start your studying soon, okay? Start your studying soon. But the main things to focus on are the homework and the lectures, the videos of the lectures. Nothing on the exam won't be content, so everything on the exam is content that we emphasized in homework and the lectures, okay? And stuff you did in recitations, of course. All right, questions before we get started? Like I said, we'll do top head at the end today. Please. What's that? It looks great. What do you mean? Yeah, multiple choice. The exams are 20 to 30 questions, multiple choice. But they're testing your understanding of things, not just the ability to calculate. So they're very much parallel, aligned with what we're after in the homework questions and in lecture, going for understanding of things. The multiple choice questions will test that kind of understanding. It won't be just calculating answers with 5 number answer choices. Lots of reasoning types of things related to what we've learned. Okay? So let's go. Here we go. So a distance a motorcycle travels from an intersection in miles is a function of the time elapsed since leaving the intersection in minutes. So you read about functions. I'm going to name this relationship G. So I'm going to put something on the screen, and I want you to pay attention to what your reaction to that is. So you think about what does it mean to you, or what does it symbolize when I put this on the screen? How do you interpret it? Okay? So when you see that, what came to mind when you saw that? What does it mean? So take a moment to think about, what does that mean? Everybody individually. Okay? How many people, when you saw that, you thought, oh, there's something I'm supposed to do. There's something I'm supposed to do. Only a few of you. Okay? All right. When we see that, if this is our goal, okay? The goal is that when you see this, you conceive it as 3 things together in harmony. First and foremost, that whole thing is the value of the dependent variable. In this case, number of miles. So as a whole, that whole thing represents the value of the dependent variable. Remember we said a variable is a letter. It's a letter that represents a changing quantity. Well, it could also be like a notation like this. So we think of this as a variable too. Now, the fact that there's 8.3, it's a particular value of the variable. But this notation as a whole, we can think of as a variable. And it's for the function whose name is G. G is the name. When the independent variable has a value of this number of minutes, 8.3. So this is the way we want to see it. We want to see it as a value of the dependent variable for a particular function when the independent variable is 8.3. Okay? So g of 8.3 represents what? Who can, in the context, who can articulate? What is g of 8.3? What is it? Yeah? Okay, so is it number of miles traveled? Yeah, yes, right. Yes, I did use traveled as the language. Okay, so we said it's the number of miles traveled by the motorcycle at 8.3 minutes. Agree? Agree with that? It's exactly what it is. It's how far the motorcycle has traveled in miles when 8.3 minutes has gone by. That's what that whole thing means. Okay? Do we know what that number of miles is? Do we have to know what that number of miles is in order to use this notation to mean that number of miles? That's the point. We can use this notation to mean whatever that value is, even though we don't know the value. And that's important, that you can use this notation to represent that distance traveled, although we don't know exactly what it is. But it has that exact value, okay? All right, let's do it again. Here we go. So here a function is defined as 3x squared plus 8x minus 17, f of x. What comes to mind when you see this notation? What does it mean? What does it mean? Yeah? Okay, it means plug in 2. How many people think it means plug in 2? How many think it means something other than plug in 2? Oh, got some of each. There's one. Okay, somebody knew. So if it's not plug in 2, what is it? Yeah, in the back.
The value of 2 as the input in the function x. I mean, plug in 2 just isn't very specific.
Okay, so what is the whole thing? F of 2 is what? What do you say it is? If it's not an instruction to do something, what is it instead?
It's the value that function f gives when
It's the value the function f gives when
the input is 2.
the input is 2. There was a hand here too. Is that what you're going to say? Very good. Okay, it's the value of the dependent. It's the same thing as before. It's the value of the dependent variable of the name of the function whose name is f when the independent variable has a value of 2. It is not instructions to do something. It stands for a value. It stands for the value of the dependent variable when the independent variable is 2. Now, in this case, we could find that value. Okay, but do we have to? Can we just use f of 2 to mean that value? Absolutely. Okay, absolutely. Everyone, the screen's open. What are you doing? So you're taking notes, right? Taking notes if you have screens open. Let's just make sure that's the case. Okay. All right. So some of you may have already found it. What is f of 2? It's 11. Okay, it's 11. If you were to, so this function then tells us how to actually get that value. Replace every x with 2 and do the computation. But f of 2 by itself means the value. It's not instructions to do something. We can use, in the scope of a problem with other functions and other values of the independent variable, we can use f of 2 to stand for that without ever knowing what its value is. Okay, given two quantities represented by y and p, suppose that p is a function of y. P is a function of y according to this. So I have two quantities represented by variables y and p is a function of y according to this statement right here. So where in the above statement, I'm going to give you a list of questions. Where in the above statement do you see the function definition, the dependent variable, the independent variable, the function name, the function notation, function rule, and the value of p? So, and then as you're answering those questions, we're going to hand out a handout. Just hold it to the side. You don't even look at it yet until you have the cue. Okay? So just Just put this to the side. You're working on this. Where in that statement, z of y equals 3y squared plus 8y minus 17, where in that statement can you see each of those 7 things? Okay? Go. Morgan, can you help me, class? And Sergey. Just put this to the side, just ignore this, you're working on the activity on the screen. Okay, where do you see the function definition? Where do we see the function definition in that statement? To the right. 3y squared plus 8y minus 17. That's the function definition. Any other alternative? Yeah? Just we're focusing on the statement. In the statement, where do we see the function definition? Yeah? So no, okay, so you guys are just focusing here on so here, so this is the statement. This is the statement. So in each, we're just focusing on this statement right here. Where in this statement, z of y equals 3y squared plus 8y minus 17, where in there do you see the function definition? The right side. Yeah. Go ahead. The whole thing. What do you say? The whole thing. The whole thing is the function definition. The whole thing is the function definition. That defines this function. Where do you see the dependent variable in that statement? Where do you see the dependent variable in that statement? Yeah.
zy.
The left side, z of y. We just went over that, right? This is the value of the dependent variable. Z of y. Values of the dependent variable. What about the independent variable? No, just y. Just y. Y is the independent variable. Y is the independent variable. Function name. Z. Okay? Function notation. Z of y again. All right? Function notation is always noting or representing the value of the dependent variable. Those are the same. Function notation. The left side, z of y. That's what we call function notation. That's always meaning the dependent value of the dependent variable for a given value of the independent variable. Okay? Where's the function rule? Right side. The rule tells us how to get the value of the dependent variable if we knew the value of the independent. The value of p, where do you see the value of p there? Some are saying it's z of y again. The value of p is, so if p is a variable, in this function definition, the value of p is the same as the value of z of y. Okay? So all three of these things are the left-hand side. The dependent variable, function notation, the value of p. Does it make sense? How about this? Is this a valid statement? Z equals 3. Is it valid? Why not? Yeah. Okay, but why is it not a valid statement? Why is z equals 3 not valid?
It's just the name.
Z is the name. Z represents the whole relationship. It doesn't represent a variable. Z is the name of the function representing the whole thing. So this is not a valid statement. So I want you to, what's intended by this, write it two other ways. So instead of Z equals 3, what could you write that would be correct? That would have that same meaning, the intended meaning of that, right? So what would one way to do that? Someone said it before. Z of y equals 3. And what would be another way to, in this scenario, to represent that? P of 3? P equals 3. Okay, so two other ways to do that would be Z of y equals 3. That would be valid. Now we're talking about the value of the dependent variable. But what is Z of y? It's the value of the variable P. So here's two valid ways to do that. This is not valid. Because Z is not a variable. It's the name representing the whole relationship. Z represents like everything in this list. The whole thing taken together. All right? Okay, so let's do some practice here. You've got your sheet now. So this is the side of the sheet I want you to look at. The side that starts, let t equal the number, the time elapsed in seconds. So with the person next to you, if you wish, I want you to work on this, and we'll regroup in about 10 minutes and talk through some of the more challenging questions here. These are really super important questions for understanding functions and function notation and how it's used. Okay? Oh, sure. You'd love to ask. Okay, let's regroup for a moment. So we got to get number 1 right, or we'll be dead in the water. So number 1, you should have said the independent variable is t, and the dependent variable is d because of the way that this was mentioned. D is a function of t. It means d, the values of d depend on the values of t. Okay? So your t is your independent, d is your dependent variable. So using the function name w, representing the distance, the dependent variable would be w of t. W of t, function name w, independent variable t, goes in the parentheses. If you wanted, you could have said d equals that also, if you wanted to. Not required, but if you said d equals that, that would be okay too. But that's not a function definition. That's just saying that the output or the dependent variable is also called d. The definition would have some kind of formula or some kind of way of letting us know how to get values of d if we had the value of t. But just w of t is kind of what we were after in that question right there. Okay? Questions on number 1. So that should be entirely consistent with what we just talked about earlier. Okay, so now we want to use number 1 to represent, sorry, there's a typo there, it should have said a function from number 1 above. Distance traveled by the car in the first 9 seconds. Should be easy. How do we represent that? W of 9. W of 9. W of 9. Not d of 9, right? D is a variable. W is the name of the function that we use to express values of d. Okay, change in distance from 2 to 5 seconds. Okay, really important idea here, that we can take the distance, the total distance traveled in 5 seconds, and then to get the change from 2 seconds. Okay, and so couldn't we just write, instead, couldn't we just write W of 3? Can we just write W of 3? What does W of 3 mean? What does W of 3 mean? Distance traveled in the first 3 seconds. That's what that means. So this is the change in distance starting from 2 seconds to 5 seconds. Totally different animal, right? Totally different. So no, you cannot do that. There may be situations where in some where it may turn out to be the same, but in terms of meaning, it's never the same meaning, right? The meaning of W3 will never be the same as the meaning of W5 minus W2, so just don't do it, okay? Cars changing. So what is the second 4-second time interval? From when to when? T goes from? Just know, let's just talk about that interval. T goes from what to what? No, the second 4-second time interval. The second 4-second time interval. 4 to 8. That's what that's referring to. From 4 to 8 seconds. Now we can express the change in distance over that time interval, just like we did the last time. W of 8 minus W4. So notice, that's the starting value of the independent variable. This is the ending value of the independent variable. And so then when we subtract the corresponding values of the dependent variables, we get the change in that dependent variable, starting from 4, ending at 8. So now the change in distance over any 7-second time interval beginning at t equals x. So it's going to be a change in distance. So the general structure will be the same as before, w of something minus w of something. So what is the starting time? We know this should be the starting time of our time interval, right? Just like 4 was the starting time of this time interval, 2 is the starting time of this interval. So what's our starting time? X. And how long is this time interval? 7 seconds. So therefore, the ending time, 7 seconds after X, right? It's going to be, if it's a 7-second time interval, it's going to be 7 seconds later than X. So this should be X plus 7. How many got it before I did it? Some, good. That's what that would be. Starting at time X, lasting 7 seconds, so the final time will be X plus 7. Then we get that change in distance by getting those values of the dependent variable and subtracting. Questions on number 2. Really important that you can set these up, and then when they're given, you can recognize them. So now for this, what's off limits? You can't, if you want to express these, you can't use the word subtract, you can't use the word difference, you can't use the word minus, etc. All of these compute some final value. That's what you're interpreting in terms of the car. So all of these compute some final value, and you're saying, what does that final value mean? Okay, you're not going to use the word difference or minus or subtract to do that. So just take a couple more minutes, see how you do on number 3. Go. I'll let you keep working on them. You can get help outside of class, keep talking. I do want to, let's do, how about just D? Let's just see how we did on D. Anyone think they can articulate D really well? Right here, tell me. Okay, so the distance traveled by the car, starting at time equals 3, and ending at time h.
In addition, sometime after 3, represented by h.
Sometime after 3 represented by h. Okay? Yes, sir? The change in any h second interval. Is it any h second interval? Yeah. It's almost.
The change in distance in h
Okay, so the change in distance over an 8-second interval starting at 3 seconds. What do you think of that? That's what it is, okay? The starting time is 3 seconds. And we're going to get the change in distance over the next, what? 8 seconds. It's going to be, so this is the change in distance for an 8-second time interval starting at 3 seconds. Does it make sense? So all were close, and then he got it. The last one got it. All were close, though. So it's a change in distance starting from time equals 3 for a duration lasting 8 seconds. And that will be that whole thing will give that change in distance. Okay, so let's do some stuff on GC. Let's get out your laptop or do some GC. Yeah. No, Cerny's, that's just tomorrow.
Oh, okay. I wasn't sure if
Yeah, no, it's for us. It's for us, but she wrote it, not me.
Question. On the last one on there, like F, is that like the definition of the derivative? It looks sort of like the derivative formula.
Yeah, it was average rate of change.
Okay.
But we can talk later.
Okay, thank you. It was just I thought I was like,
Yeah, that's. Okay, so open up a window. Here we go. So I'm going to go fast with this first part. So we've seen direct computation. So here I've got a cost of materials in dollars for a certain rectangular box. The base dimension is L, and then and width W is given by this. This gives you the cost if you knew the length and the width of the base. This gives the cost of the box. All right. So suppose we wanted to calculate the cost of a box that was 854. So we've seen this before. You could just come up here and do 4 times, what is L? 8 times width is 4. Make that bigger. Okay, and then plus 288 divided by, what's my length? 8 plus 96 divided by the width. Width is 4. And then as soon as you get that expression finalized, boom, it tells you the answer. We saw this before, right? So here, this is the cost of a box whose length is 8 and whose width is 4 according to this formula that calculates the cost. And I just put the numbers in. 4 times 8 times 4, 288 over 8, 96 over 4, following the formula. As soon as I get the formula correctly put into the command line, it tells me the current value, so it's a $188 box. Okay? All right. So the next thing you could do is we can actually use parameters and formulas to do this. So what I can do is I can define a formula, a cost formula. And so I can do capital C for cost equals 4LW plus 288 divided by L plus 96 divided by W. Now, why don't I get a number? Because I'm not computing something, I'm defining a formula. So it knows that I'm just defining a formula, I'm not computing anything in particular. So what I can do now is I can define what L is. L equals 8, and W equals 4. And now, if I just type capital C, look what happens. It goes to the definition of C that I gave it and computes it. Wow, I was right. But it gets a lot better than this. Okay? It gets a lot better. So what do? We define the formula, then we defined the current value of L, the current value of W, and now by just punching in C, it gives me the current value of C according to the formula that I defined. The order of these lines does not matter. The order of the command lines, you could put them in any order and you'd have the same result. Okay, and so then the next way we could do and then looking at why is this convenient? Why? Because we go on to the next box. All I have to do is go to that line with L and change L to 2.6. Change W to 5.9. Well, not a great example. Let's do the last one. 10 L to 10 and W to 7.25. And now automatically C updated, right? Because it's going to evaluate C according to my formula for now these new values of L and W. And I get the value of C, 332.041. What's that? Okay. All right, so then the last thing that graphing calculator, the way we can do this is using functions and function definitions and function notation. Okay, so everything that we've learned so far in class is completely consistent with the way that GC, the way that you define functions in GC. Okay, but there's an important distinction here. If I wanted to set up this function, when I put my parentheses, I don't want to do shift 9 because then it would think multiplication, right? It would think C times. So you're going to do control 9, which indicates to GC that this is a function definition, not multiplying by what's in parentheses. Does that make sense? And look at the difference. If you do shift 9, all right, I'll do that and then new line versus control 9. Watch. Do you see the difference? Control 9 is closer to the function name. So if you just do shift 9, that first one would represent whatever the value of C is times whatever's in the parentheses. We don't want that, right? We don't want that. C is, so we're going to get rid of this. This is what we want. C control 9. Okay? And then what are our variables? Our independent variables. We have 2, so we can just list them with commas. So most, for the course, we'll usually have 1 independent variable, but this isn't hard. Here we have 2, you just use a comma. So there's 2 independent variables and 1 dependent variable, the cost. Okay, and so it equals, the rule is for LW plus 288 over L plus 96 over W. So what is that? That's a function definition, just like we talked about. You've got everything there. You've got the function notation representing the value of the dependent variable. You've got the independent, in this case, variables. You've got the rule. You've got, what else am I missing here? The name is C, okay? So now, how will if I want to calculate the cost of that third box, what will I put in the command line now, based on what we've learned in class today about functions and function definitions? What am I going to put on a command line in order to, see if you can do it, in order to calculate the cost of the third box? See if you can do it. You want to, in the most simple way possible, calculate the cost of the third box using what we talked about in class today. Who can do it? Go. And see if it works. What was it, 322 something? 332. So, what should I put on a command line that's going to tell me the cost of that third box there is 332? How many people think that? How many people got it? Keep working on it. Really important. So the question is really, how do you represent the cost of this box with the function that I've defined? How to represent on one line, how to represent the cost of this box. We've been doing it all class long. And if you represent it, GC will tell you the value. If you represent it, GC will tell you the value. How to represent the cost of that box. Now how many people have it? More? Good. Keep working. We did it all class. We did it all class. How do you represent the cost of that box? Given that definition. That's a matter of what? Representing the value of the dependent variable. How do you represent the value of the dependent variable? Do more people have it now? Trying to represent the value of the dependent variable, which is the main theme today. How do we do it? We do it with function notation. Function notation represents the value of the dependent variable. If you correctly put in your function notation, it'll give you that value of the dependent variable. Everyone who has it now, raise your hand. Function notation, is it the left side or the right side? Left side represents values of the dependent variable. Which value do we want? When what? L is 10 and W is? Look at that. Completely consistent with everything we've learned in class today and what in your reading. Function notation is very powerful for representing values of the dependent variable. We're going to do it all semester, and it has to be on the tip of your fingers. Okay? Yeah? Do you have the right definition? Definition right? Something's, I can come look at it in a second. Okay, now how about, can you represent the change in cost of the box if we were to take this box and then extend its length 5 more feet? So I want the change in cost from this box to the box who has a length 5 foot longer than this one. In one command line, represent that change in cost. I'll write it out. Yeah, on a new line. So on a new line. So represent the change in cost if the box above if the box's length was extended 5 feet. Represent it in one command line. So that the number GC calculates is that change in cost. Anybody have a number yet? What is it? $135. Someone else getting that? How much? $467? Sounds like too much of a change in cost. 135? What'd you get? 135. 135? The change in cost. Represent the change in cost if the box length was extended 5 feet. Width stays the same. So it would be capital C of 15, 7.25 minus $135.40. The change in cost if the box had a length extended from 10 to 15 feet. I said change every time. For just of the 15 feet? Yeah. Okay, doesn't make sense. So this is crucial that you can, in graphing calculator, being able to use function notation to create expressions and create equations, using equations is crucial for the things we need to do. So you have to have a really firm grasp of what is function notation telling us. It's telling us what? The value of the dependent variable for a given value of the independent variable. Okay, so do we have a couple minutes? Yeah. Well, we have top hat too. Okay, so we were using capital C and L and W. There's some parameters, some symbols that are already reserved in GC for special use. Okay, so the ones we were using, capital C, capital L, capital W, those are called free parameters. We can define them and work with them as we like. But these are not. So first of all, X and Y, really important. X and Y are reserved to represent the values on the X and Y axes. So they represent variables. They represent all values on the x-axis, all values on the y-axis. And so it's X and Y that prompts GC to give us a graph. Okay? So when we use X and Y in a command line, X is going to stand for all X values, and Y is going to stand for all Y values, and it's prompting GC to graph. Okay? Another one these are reserved, E and pi, you'll use those. Those are fixed constant values. Little t is reserved for parametric variable. You'll learn about parametric functions and parametric, that'll be Calc 2 and Calc 3. So and then n we saw before, whenever you put n, it brings up that slider below the graph, right? So as soon as you type n into a command line, that slider pops up, and then you can control the value of n. Okay? So you're safe with capital letters, okay? If you use capital X or capital Y, capital T, those are all safe as free symbols to use, okay? All right, so let's just try a little bit of this, not much. So this is your other side of your sheet. Okay, it says the height of a sunflower is modeled by this function, capital H of t. Here's the rule, where H of t is the height of the sunflower in centimeters, t days after the seed germinates. Function is only valid for the first 10 days of germination, so only for t, so this is the domain, right, of our independent variable. Our domain of the independent variable is from 0 to 10. T takes on values from 0 to 10 for this function to make sense. Okay, so let's try A through C. Try A through C, and then we'll okay. What does H of 6.14 represent? If you calculated the value of H of 6.14, then I caught you. I got you in your old habits. Okay? That is not, H of 6.14 is not it's not instructions for you to calculate something. I asked, what does it represent? What does it represent? It represents the height of the sunflower after 6.14 days. I never asked you to calculate that value. So this is just a check. Did you automatically just say, oh, I got to find that value? Okay, then that's kind of conditioning from the way you saw functions in the past. Now the way you want to see that is, oh, that represents the value of the dependent variable when the independent is 6.14. I can calculate it if I want, but I don't have to. I can just use h of 6.14 anywhere that I need that value. Just use that notation. Okay, so what about h of q equals 6.14? Q represents number of days that it takes to grow 6.14 centimeters. Okay, let's define it. So I'm going to do capital H, and then make sure, Control 9. And I said use A, so we can use any symbol we want to hold the place of the independent variable. This was given with little t, and remember, little t is reserved for other stuff in GC. It's a reserved parameter, so we'll just use something else. Use little a. It's just a placeholder. So anywhere there's an a in the rule, that will be the value of the independent variable. So 0.13a. Remember, cubed and squared, you can just do shift 2 will square, shift 3 will automatically cube. But now if I define it in terms of a, I've got to include a in the rule. It's got to be, the a's have to match up. My independent variable in the rule have to match up with how I define it. Thank you. I just noticed that. 1.7a squared minus 0.6a. Okay, does it graph it? If I hit enter. No, why not? What prompts GC to graph? X and Y. So what does this? This defines the function. We can do all kinds of things with this. We can find different values of height just by using function notation like we did in the box problem, the cost. I can do h of 4 and it'll just give me the height at 4 days. Okay? I can do changes in height by setting up those differences, right? So I can use this, and if I want to graph it, what do I want on the y-axis? Do I want the time or the height? If it's dependent. Independent on what? No, independence here, we want, conventionally we use independent on x. So then what will this be, x or y? Oh, they're fighting. Fight. H of x equals to y. We want our values of our dependent variable, function notation, to be on the y-axis when our independent variable is on the x-axis. And what we want to, remember we restricted it. We can use a comma and say only for x values, what? From 0 to 10. And if you want less than or equal to, on Mac it's option, comma. Anyone know what it is on PC? Control shift, comma, control shift period. Now that's going to graph our function h only for the domain, x values from 0 to 10. But we need to, we'll do this, you do this in, and make a better color. There we go. So you guys will do the axes and recitation, yes? Shifting and zooming on the axis. But with a good picture of this, then looks like this, showing what? As time increases, right? These are variables, right? So when you look at this, you got to think a dynamic situation. Time is increasing. As time increases, the height increases according to this set of correspondence points. Okay, we got time for the Top Hat quiz. So there's still unfinished business on here. Encourage you to work on it, okay? Top Hat.